Hello, and welcome to the Pre-Calculus Podcast. I am your host. This is episode 11.8. This is our last episode of this season, whatever we want to call it. Today we're looking at probability. Now, for the most part, most of you probably have heard about what probability is, but what we are going to be looking at specifically is probability and still using permutations and combinations like we talked about in a previous episode. So, let us begin. So experimental probability. So experimental probability, which we denote as P of E. E is the event of something occurring. P means probability. So P of E is equal to M over N. Now you could use any variables for this. I'm just using M and N. M is the number of times that an event occurred. N is the number of times that you observed the overall event happening. So if, let's say, I want to talk about, what's the probability of me flipping a coin 3 times and landing on 2 heads, or let's go drawing a card, drawing a card out of a deck, and we have, what's the chances of us drawing a heart? Well, if the first pull I have was a heart, that means the probability was 100% because it's 1 out of 1. If the next 3 cards I pull are not hearts, it ends up being 1 over 4 because I've gotten 1 heart, but I've drawn 4 total cards. Now let's say the next 5 also were not hearts. That means that my probability now, my experimental probability, has gone from 1 out of 1, or 100%, all the way down to 1 out of 9. Because I'd have 9 total pulls and I've only pulled 1 heart. So that's how experimental probability works. So experimental probability is what actually occurs when you pull it. You could have something that's really high. You flip a coin 3 times, what's the probability of all of them being heads? You could flip 3 heads in a row. The probability would be 100. You could also flip no heads, which gets you a 0%. Okay, so experimental probability is what you observe and what actually occurs for it to happen. Next up is our theoretical. So theoretical is what should happen. So if I draw a card, out of a deck, the probability that it's a heart is 1/4. It's always 1/4 in a standard deck because 1/4 of the deck is hearts. If I flip a coin, what's the chances of it being heads? It's 50%. It's always 50% with a standard coin. Rolling a dice, what's the chance of rolling a 5 on a die? That is 1 out of 6. Okay, it's theoretical. This is what should happen. And the idea is that if you do an experiment long enough, if you do enough experiments, enough trials, what ends up happening is that you approach this theoretical probability. Okay, it's kind of like its limit approaches this theoretical. Now, it won't get exact because there's other things in the world that are affecting it, but that's kind of the goal, is as you do something more and more and more, you get closer to the theoretical. Okay, if a team has so like in statistics, if they're going, oh, this team has a 20% chance of winning this game, that means that if these two teams were to play in that situation 100 times, they should win 20 of them. Okay, now they could win that first game and then that's it, because after that probabilities change because of how the world works. So theoretical is what the probability should be all the time. Okay, so that's why it says here in a given set. Okay, so a set would be like heads and tails. That's a set. 1, 2, 3, 4, 5, 6. That's a set. All the cards in a deck. That's a set. So let's talk about some properties with this. So the probability of an event, if it has no chance of occurring, what's the probability of rolling a 12 with 1 die on a standard 6-sided die? That probability would be 0 because it can't happen. You can't roll a 12 on a 6-sided die. So that means that the probability would be 0. If the event will occur, so if it's assured that it will happen, so rolling a dice, you'll get a number between 1 and 6. Okay, that probability is 100%. So that probability would be 1. Okay. Usually when you're talking about probabilities, you're not talking them in percent though. You're talking about them in decimal. Because what we do with that is that if we know, oh, there's a 50% chance or 0.5 chance of us rolling a heads, we take that, or flipping and getting heads, we multiply that by 9. So that means if we flip it 9 times, that means we should get approximately 4.5 heads. Okay. Now you see it's a decimal, but we're predicting what we should get, not what the actual number is. Okay, so let's look at this example. So 3 cards are drawn from a standard deck of cards. What's the probability that all 3 cards are face cards? Okay, so first thing we want to know is how many, when we draw the 3 cards, we want to know what's the probability of them, again, just being drawn. 1, 2, 3, 1, 2, 3. Okay, we're not drawing and then changing the probability. So we want to do it as one big problem. So what we have to do is, what's the probability of getting, or how many groups of 3 can be formed from a standard deck? Well, a standard deck of cards have 52. Okay, so it's 52. And since we're just talking about a group, we're not talking about the order in which they're picked, it'd be a combination with 3. And this is the grand total. Okay, so that's the total that's going to occur. Now we have to see, okay, what's the probability, or how many groups from face cards can we get groups of 3? Now, it's the same thing, but how many face cards are there? Well, there's 3 face cards, we're saying here. The Jack, Queen, and King. Jack, Queen, King. So there would be 12. And we want a group of 3. And that's going to be our top number. So you'd find both those combinations. You want to find how many groups. So we can make 220 groups of face cards, groups of 3. But there's 22,100 total groups of 3 we can make. So we take that, we do this division, and that ends up being our probability for this. Okay, so these are going to tie in permutations and combinations to help you find your probabilities. Okay, so remember, a permutation is where the order matters. A combination is just looking for groups. The order doesn't matter. Okay, so here's your homework from this section, page 851, numbers 2 through 28, and I hope you have enjoyed this.